All right, so in question 4.4, what we've got basically is some kind of roller coaster. And in this roller coaster, there's some kind of vehicle in which the victims sit. And initially, that vehicle and the people in it are just sitting there quietly, not going anywhere. Then, someone comes along, turns on a big fat magnet, and makes this car and the people in it accelerate for 7 seconds. And at the end of that 7 seconds, their speed is 45 metres per second. And what the question wants to know is, what was the average net force acting on that vehicle and the people in it over those 7 seconds? Because, of course, in order to make something accelerate, then you've got to apply a net force to it by Newton's first law. But anyway, let's just first of all write down what we know in this question. So what we know is we do know that the initial speed of this thing, I'll give it a symbol. Let me call it V0. That was equal to 0 metres per second. We also know the final speed. Let me call that V1, and that was equal to 45 metres per second. Memory serves, read correctly, yes it does. And what else do we know? We also know that the acceleration took place over 7 seconds. Or the speed change takes place over 7 seconds. I'll give that a symbol, I'll call it T, and that's 7 seconds. And the other thing we know is that the mass of the vehicle and the victims is 5,500 kilos. And I'll give that a symbol as well. Let's call it M, is equal to 5,500 kilograms. Now, to calculate the net force that you need to make something accelerate, we should use Newton's second law. That's the law that relates net force to acceleration. So we can say that by Newton's second law, the average net force acting on the vehicle and the people in it is equal to their mass times their acceleration, so times their average acceleration. So in fact, the acceleration of these people may not be uniform over those 7 seconds. It may change, and because the force may be changing as well. But what we're going to do is we're going to calculate the average net force, which is found by multiplying the mass times the average acceleration. Now this is kind of handy because we do have a definition for what average acceleration is. So here the average acceleration is going to be equal to the final speed, v1, minus the initial one, divided by the time over which that speed change took place. So divided by this t, which is 7 seconds. And so if we just go ahead and plug these two, if we go ahead and plug this average acceleration into Newton's second law, so if we call this 1, so plug, and we call this equation 2, we can say plug 2 into 1, and that gives us that the average net force then is equal to mass times V1 minus V0 divided by T. And now we can just chuck these numbers into this, and so we get this. I get that the average net force was 35,000 newtons or thereabouts, so that's approximately equal to 35.4 kilonewtons.